So, hello everyone, my name is Zane Luis V. Hernandez, and well, here's our short group presentation on what is a MergeSort algorithm, or rather, what we call a divide and conquer algorithm. So, a MergeSort algorithm is an algorithm that divides your arrays into smaller subarrays until you have, well, one subarray that contains only one element, and then we merge those back together. This process requires log n divisions because you're essentially dividing the array in half at each level of recursion until you reach one array. So the time complexity of this would be log at n levels of recursion, where n is the amount of levels that you have, and each level involves merging those elements together. So the total work done is an O n log n of time complexity, right? Where n is your level of recursions and the n is the amount of elements that you have. So, what is the efficiency of such algorithm? Well, the key to its efficiency is that it constantly divides the array into smaller parts and then efficiently merges them back together. It ensures that it has a stable time complexity of O n log n regardless of the initial ordering elements. What this means is that no matter how many orders of elements that you have, because it divides it into smaller parts and at a consistent rate, it allows you to have a more stable time complexity, right? So one way to visualize this is through the MergeSort visualizer in Java, right? For example, here we have a MergeSort visualizer that we are going to put on the screen right now, which shows how a MergeSort algorithm works. As you can see, it divides the arrays it gives into its smaller bits, combines them together, then it divides them, it works on different parts of the array, combines them together, etc. So this is one way to visualize it. However, as you can see, it's kind of confusing how it works because, well, it's not really showing you like the simple parts of it, right? It's showing you already the final product. So I'll let this run through and I'll meet you guys next on my next sort of visualizer for it, which would be in Minecraft. So I'll see you there. So here we are in our beautiful Minecraft world. So how does a MergeSort algorithm work? So let's say we want to create this crafty crushing wheel over here. So how do we do that? Well, let's check. So here we have the crafting recipe for it, right? So basically how a MergeSort algorithm works is that, let's say we have a set of cobblestone and a set of sticks, or we can call them the data. Right. So what the MergeSort algorithm does is it splits them off into an array of its own, or a single array, like so. It splits them off, and then it checks which one is smaller or little, sorts it out, and then merges them all together to create the final array of product, which is a sorted array. So how does this look visually? So here we have our own little contraption that I've made to better visualize this out. So let's put, let's say, a unsorted array here. You're probably wondering, why am I putting an unsorted array? That's because this kind of what, let's say, a method I said of MergeSort is the bottom up method, which basically means that we'll start from the bottom at single array digits instead of splitting it down, because there are two ways of doing MergeSort algorithm, which is the top down method and the bottom up method. The difference is that in the top-down method, we start with a full array and split it until we have single array. And in the bottom-up method, we instead have them in a single array already, and then from there we start the algorithm. So let's test it out in function. So as you can see, it pushes out all of these numbers into their own little chests. And so let's go all the way over here. So let's check the pipes if there's any extraction modules that we don't want there. Oh, never mind. It started extracting them. So as you can see, let's move over to back into where it belongs. So as you can see, in the conveyor belts. It put them all into the single array over here, and all those single array chests that you can see over there that are connected to one chest up there. So how this works is that the algorithm will pick up what is little or what is less than the number, and it will put them into its new array, which is over there. So let's see that in action. So here we go. So now, as you can see, it arranged itself to 2, 6. I'm pretty sure I placed already extraction modules on them, so it should be already sorted. So here we have a 3, 8. Over here we have a 4, 7. And over here, we have a 1 and a 5. So what will happen next? Well, it will then again sort it out and check from the nearest two objects of arrays what is smaller, and sort it out in their own new array over here and over there. So let's check it out. Over here, up here, and over there. Okay. So this will be a bit slow, but it should work. So here we are, and over here as well. Okay. So well, while we're waiting for that one, let's check this chest over here if it is already sorted. And boom, we have it sorted here. 1, 4, 5, 7. And over here, I'm pretty sure it's already done. We have 2, 3, 6, 8. So it's already, sorted. So then again, it will check again from both of the chests what is less than or greater than, or depending on what order that you set it on, and it will then, based on that algorithm, set it and then sort it all together and merge it into one final chest, which is our final array over there. So let's put extraction modules here. As you can see, it's sending it out into its own chest. It's gonna sort it out, what is greater, what is smaller, what is ascending and what is not ascending. And then let's check the final chest over here. As you can see, it is already arranged 1, 2, 3, 4, 5, 6, 7, 8, compared to the earlier ones where it was mumbled and jumbled, right? So that's how it works. It first divides it, and then it picks out which one is smaller and which one is not, sorts it into a new array, and then picks the closest array to it, it's over here, and then sends it to another array or a new array, and then picks out the next closest array that is also of the same size, and then it will rather not the same size, but rather the nearest array that is already completed, and then it will sort it out on one last check over here, sort it out into its full-blown sorted algorithm. So how do we program this into code? Well, I'm not gonna code it here because this is Lua, and you can't really call Lua a Java program. So let's move it on back to the IDE instead. So we're back in our IDE, and here we have the MergeSort algorithm. So let's break it down step by step. First of all, we get here the length of the array, and we return null if length is less than or equal to 1, or we return nothing. Basically, what this means is that if all of the data is already split and we're already in a single array, why not just return nothing, right? And then we have here our the middle point of the array, and then we take our left side and our right side of the array. We put them into temporary arrays called left and right. And then here in this little for loop right here, what this basically just means is we'll put them all into their own array, split them up until we have such a time where we have a single data array left to merge together. This is why we have a merge underscore left and merge underscore sort right. Okay, so now let's put this back all together. So then we go into our merge algorithm. What this is a merging algorithm that will merge all of our single array data together back into its own single array. So here we have it will take the left, right, and the array size, right? So it will first find the length of the left side and first find the length of the right side. It will then initialize L, R, and I values, where L is the amount of data in the L side, and R is the amount of data in the right side. So basically what this means is that while L is less than the left side and R is less than the right side, we will just basically put them into their arrays, right? So here we have here our first algorithm. If left array is less than the thing in the right array, in the new array we will put the first the left, and then we will increase I++ and L++ to make sure that our while loop is not never ending. Else we'll just put the right array into the first slot, and then we will do an I++ and an R++ here, basically moving to our next value data within the right array, right? And then it will merge those together, and then we have here our next while loop to make sure that it is merging together. So the moment that this is, let's say, size 4 already, right, and we will then find next over here. So while L is less than the left size, we will arrange them all together into their own array again to double check for, well, any inconsistencies, and of course to make sure that the left and right side is fully sorted out together, right? So while the L is less than left size, the position at array at this position would be equivalent to the left, and while R is less than the right sides, we will put them into their own little thing. It's basically just the same thing as this one, but instead of putting it at and an if and else, we will just put that all together. So let's try this out right here. So we have here our MergeSort underscore sort this array, because this only accepts the array. So let's try it out. So our initial value were 3, 6, 50, negative 70, 14, 10. As you can see, it arranged it at the ascending order, and here are the elements. So this is the working code for the MergeSort algorithm, and I hope you did enjoy the video, and see you next time. Goodbye.